Assalamu alaikum. Now I am describe my case study round 2. Here the math is capacitance of a three-phase line with equilateral spacing, and a three-phase 60 Hz line has flat horizontal spacing. The conductors have an outside diameter of 3.20 centimeter with 11 meter between conductors. Now determine the capacitive reactance to neutral in ohm meters and the capacitive reactance of the line in ohms if its length is 200 km. And B. Solve the above problem while taking into account the effect of ground. Assume that the conductors are horizontally placed 24 meter above ground. Here my rule: PQXY, P equal to 4, Q equal to 1, X equal to 0, Y equal to 1. And after I put the value in X, Q and P, I get the diameter 3.2 centimeter and 11 meter between conductors, and the conductors are horizontally placed 24 meter above ground. Now we get the solution. We know DEQ equal to the two conductors distance of two conductors, the length of two conductors, 11 into 11 into 11 into 22 root over, equal to, we calculate this and we get DEQ equal to 13.86 meter, and the radius are equal to, here the diameter equal to 3.20 centimeter, we convert it to meter, 0.032 divided by 2, here r equal to radius, so it is divided by 2, equal to 0.016 meter. And for this math, here the diameter and the length both are present, so in this situation the XC is constant, and it for the neutral capacitance to neutral has been determined. The capacitive reactance existing between one conductor and neutral for relative permittivity, and we get for XC equal to 2.862 divided by 60, here 60 is the Hertz frequency, into 10 to the power 9 ln D by R, DEQ by R. Here DEQ equal to 13.86 meter, and R equal to 0.016, and we get the capacitive reactance 3.227 into 10 to the power 8 ohm meter. Now for 200 kilometer we convert it miles. If we convert it miles, then we get 124.274 miles, and for 200 kilometer or 124.274 miles, we get the capacitive reactance XC equal to above frequency 3.227 into 10 to the power 8 ohm meter, 3.2 227 into 10 to the power 8 divided by the mile into mile 124.274 into 1609. After divided, we get the capacity reactance equal to 1613.85 ohm. This is the answer. And for B, if we imagine this, we get 11 meters, 11 meter, 24 meter and 24 meter. Image search above the ground. Here for B, above the ground, if we sketch this picture, we get this. And from these rules, we get H1 equal to H2 equal to H3. The three are also same, equal to 48 meter, 24 plus 24 equal to 48 meter, and H12 equal to H23 equal to root over 48 whole square plus 11 square meter equal to 49.244 meter, and H31 equal to if we describe it as 31, we get root over 48 whole square plus 22 whole square meter equal to 52.801 meter. Hence DEQ equal to, we know D equal, we get D equal to 13.86 meter, and the radius R equal to 0.016 meter. Now with the final capacitive reactance equal to 2.862 divided by 16. This 16 is the frequency hertz, into 10 to the power 9 into ln DEQ by R minus 1 by 3 ln H12 H23 H into H31 divided by H1 into H2 into H3 ohm meter. After we divided this, we get 4.77 into 10 to the power 7 into ln DEQ equal to 13.86 divided by R equal to 0.016 minus 1 by 3 ln H12 equal to 49.244 into H23 equal to 49.244 into H31 equal to 52.801 divided by H1, H2 and H3 equal to 48 into 48 into 48 ohm meter, and we get the capacity reactance 3.225 into 10 to the power 8 ohm meter. Now for the 200 kilometer, we convert it the miles, so 124.274 miles. For 200 kilometer, the capacity reactance XC equal to 3.225 into 10 to the power 8 ohm meter divided by the miles 124.274 into 1609.34. We convert it, so, and after divided we get the result 1.612 kilo ohm. We get actual 612 something. After 1000, after this result we divided by 1000, we get 1.612. Thus we write kilo ohm. This is all my case study. Thank you everyone.